energy terms are also involved in reactions. Energy can be either absorbed or released. So if energy is written on the reactant side, do you remember which side is the reactant side?
The left. The left. The left.
So reactants,
right.
yep, give us products. So if it's written on this side,
You don't know left and right.
it means it's absorbed. Now,
I still have to do this.
if energy is on the product side, that tells us it's released. Sometimes, and this is just sometimes, not every time, but sometimes a negative sign equals exothermic. Okay, we don't do it every time. I think some of the saplings you've seen that negative sign in the answer, that says it's exothermic, but it's not every time, so it's kind of what it's telling you. So again, determine if the reactions are endo or exo. We see the energy, so this is the energy, the kilojoules. Is it on the reactants or the products? So that means it's released, which is, if something is released, it's going out. It's exo. Okay, now this energy again on the
Exo. Endo.
endo, on this side, exo, on the reactants. You can always refer back to these notes.
KJ.
Yep, the Kj, that's the energy, that's like the heat released, right? So, or absorbed. So again, if it's on the products, it's always going to be exo. It's released. The energy was released. It was like hot. If it's on the reactant side, that means it was taken in, the heat was taken in. That's an endothermic reaction. All right? So we can actually use this to help us do stoichiometry. So let's balance the following. Actually, we did it a couple pages before, didn't we? Is it 1, 3, 2? Thank you guys so much. Okay, so do you remember when I did the whoosh? You didn't see it, did you, Karina?
Yeah, you were.
The whoosh bottle?
No, I didn't, but I saw a story.
Did you? Okay. So when I did the whoosh bottle, would you tell someone that's endothermic or exothermic? It's a lot of heat, so that would be exo. On which side of the equation should it go then?
Can you move it out?
I'm so sorry. So if it's exothermic, which side? Reactants or products? If it's exothermic.
Product.
Yep. So you guys are getting it. Excellent. So now let's write the complete balanced reaction below. We just include the 1, 2, 3, 5. Where should I include it? On the product side. So let's just write it. C2H5OH 3O2. There should be an arrow, my fault. 2CO2, 3H2O, and then finally include my 1, 2, 3, 5 joules. Remember, that's the amount of heat that was released in that whoosh bottle. Lots of energy.
Is that kilojoules?
It is kilojoules. Thank you. I'm so used to joules. Kilojoules is just, again, it's in the thousands versus not vegan. Okay. So we have this, and again, we're just including the energy now, and that tells us exothermic or endothermic. So on your next page, again, same equation. We can use this stoichiometry to do lots of math. How exciting.
No.
So it's kind of nice when things work out. That's why scientists do this. They do the experiments, and then they're like, let me see if I can mathematically figure this out. And they do. It all works out perfectly. It's kind of strange. So again, start with what you're given, 5.21 moles of oxygen. I want to go from oxygen to kilojoules. How do I do that? The way to do that is, again, if I want to get rid of moles of oxygen, top or bottom? Bottom to cancel. And I can actually, because it's in this equation, I can just put kilojoules up here. How crazy is that? So, I know. Aren't you excited?
No.
I love the enthusiasm.
123.35. I mean,
We should not
1, 2,
put
3, 5 on top.
1, 2, 3, 5 on top, and then over 3. How simple was that? You guys are experts.
It wasn't.
So,
Just the one-step equation.
Hallelujah.
some of them might be a couple more than one step.
But not like the
Grams to grams,
Yeah.
it usually isn't that much. That's a lot. Divided by 3. Are people getting 2,144.78, and the units are kilojoules. All right, so now let's start with the next one. We start with 600 kilojoules, and I want to go to moles of ethanol. So to get rid of kilojoules, Karina, top or bottom? Perfect. And I want to go to moles of ethanol. I can do that because ethanol is right up here. C2H5OH.
So it's 1 moles of ethanol.
Over how many kilojoules?
1,235.
So I do 600 times 1 divided by 1,235, and that gives me 0.485 moles of C2H5OH. Are you guys getting the hang of this? It's not too crazy? Now I'm just starting with 2,500 kilojoules, but I want to go to grams of water. So let me show you that. That's like one extra step. Are you okay, Blake? Something like crazy?
No, I was just trying to guess how long it was.
Oh, okay. Thanks. Don't worry about it. Okay, so we start with 2,500 kilojoules. And I want to cancel kilojoules, Blake, so top or bottom? Perfect. And I can't go to grams. There's no grams up here. But what can I go to? I can go to moles of water.
Does lemon make you burp?
I don't know. So we have 1,235 kilojoules going to, we have 3 moles. But can I go moles to grams? So moles of H2O gives me grams of H2O. 1 mole equals, does anyone memorize how many, this molar mass?
52.0.
Not 52. So you add the 2 H's because it's like 1.01 times 2. Yep, 16.
No, there's 1.
No, you do not count the coefficient. That's a great question. And that's like, everyone does that. That's so common.
Miss Farron, can you screw up, please?
Yes.
You told me.
So we do 2,500 times 3 times 18 divided by 1,235, and that gives us 109.43 grams of H2O. Is there anything here that you're like, I'm totally not getting this, this doesn't make sense?
I'm not getting it. Doesn't make sense.
Okay, let me do one more. Again, start with what you're given.
Wait, is this gonna be on the
3.16
quiz
grams
Yes.
of carbon dioxide. Okay, so Angie, I want to get rid of grams, top or bottom.
Bottom.
So grams of CO2. I don't have any grams up here, but what do I have up here? Moles. So I can go grams to moles.
Yep.
Does anyone know the molar mass of CO2? Yes. So this is the periodic table equals 1 mole.
44 point what?
This was-
Switch it up.
I can scooch it up. So now I go moles of CO2 to, where do I want to go? Kilojoules. Can I do that?
Yes.
I can. So what numbers do I put? The kilojoule is 1, 2, 3, 5. And then how many moles of CO2?
2.
So I do 3.16 times 1 times 1,235.
I'm so sick of numbers.
Divided by 44.01 times 2. All right, and that gives us 44.33 kilojoules.